Hello friends, welcome to the CS Tutor. In today's lecture, we are going to discuss about the shortest remaining time first or SRTF CPU scheduling algorithm, which is a preemptive type of algorithm. Preemptive algorithm is an algorithm when a process can be terminated by another process before its completion. So here an example is given, and the six processes and their arrival time and burst time are also given in millisecond. So let us solve this problem now. So you can see that P1 has the least burst time, that is 0 milliseconds. So P1 will be scheduled first in the Gantt chart. So how much time will it go? It will go for 0 to 1 millisecond, because in SRTF we will always schedule a process for 1 millisecond and calculate the remaining burst time or execution time for that process. And now it is the turn to calculate the remaining burst time for process P1, as 1 millisecond has already been done. So P1 has now the burst time 6 millisecond. So now we have to look that at 1 millisecond whichever process has come. At 1 millisecond process P1 and P2 has come. So among P1 and P2, which has the least burst time? Process P2 has the least burst time, so P2 will be scheduled. P2 will be scheduled for 2 millisecond, 1 to 2 millisecond. So the burst time for P2 will be now 4 to 5 to 4 millisecond. Now it will be 4 millisecond. Okay. After that, after that, you can see that now we have to check that at 2 millisecond whichever process has come. At 2 millisecond process P1, P2, P3 has come. So among P1, P2, P3, which has the least burst time? P3 has the least burst time, so P3 will be scheduled for P2. P3 will be scheduled for 2 to 3 millisecond. Okay. Now P3 has the burst time 2 millisecond. Now we have to check that at 3 millisecond whichever process has arrived. So at 3 millisecond process P1, P2, P3 and P4 has arrived. So among process P1, P2, P3 and P4, P4 has the least burst time, so we will schedule P4. We will schedule P4 now. So P4 will be scheduled for 3 to 4 millisecond. So P4 is done. So P4 has the burst time now 0 millisecond. Now at 4 millisecond, whichever process has the least burst time will be scheduled. You can see that at 4 millisecond, process P1, P2, P3, P4 and P5 has come. So among process P1, P2, P3, P4 and P5, whichever process has the least burst time, process P3 and P4 has the least burst time, that is 2. We will not consider P4 because P4 has already done, so we can cancel out, because P4 has the burst time 0, so P4 will not be considered further. Okay. So among P1, P2, P3, P5, which process has the least burst time? Process Process P3 and P5 has the same burst time. So whichever process will be scheduled, process among process P3 and P5, whichever process among P3 and P5 has the least arrival time will be scheduled first. So among P3 and P5, process P3 has the least arrival time, so P3 will be scheduled first. And it will go up to 5 millisecond. It will go up to 5 millisecond. Okay, so P3, now the burst time for P3 is 1 millisecond. Now at 5 millisecond, whichever process has less burst time among process at 5 millisecond, you can see at 5 millisecond all the process has come, that is P1, P2, P3, P4, P5 and P6, all the process has come at 5 millisecond. So among all this process, whichever process has the least burst time, process P3 and P6 has the least burst time, but the arrival time of process P3 is less than the process P6, so P3 will again be scheduled for for how many millisecond? You see, uh, when all the process will be arrived, that is when all the process will be arrived at 5 millisecond, all the process has arrived. So after that we need not to schedule each process for only 1 millisecond. So when all the process will be arrived, it will be simply a SJF, that is shortest job first scheduling algorithm, or in other words you can say that when all the process will be arrived, we will not go for scheduling each process for 1 millisecond. We will simply do the same procedure when we what we did in our shortage of first algorithm. So as all the process has arrived at 5 millisecond, so afterwards we will not schedule each process for 1 millisecond. We will be schedule It will be scheduled for up to its burst time. So as you can see, P3 has the least burst time, and P3 and P6 has the least burst time, but the arrival time among P3 and P6, P3 has the least arrival time, so P3 will be scheduled for 1 millisecond, because it is actually one. You can see for P3 the burst time is 1, that is why we are going for P5 to P6 for just 1 millisecond. Okay, but now you can see that P3 has done. So only P1, P2, P5 and P6 are left. So at 6 millisecond, all the process has already at 6 millisecond all the process has come, because you can see at 5 millisecond all the process came earlier. So definitely at 6 millisecond all the process has come. So you see you see that now which process has the least burst time? Process among process P1, P2, P5 and P6, process P6 has the least burst time, so P6 will be scheduled for 6 to 7, because the burst time for P6 is 1. Now P6 has done. Now among the process P1, P2 and P5 which has the least burst time, process P5 has the least burst time, so P5 will be scheduled. Now you can properly understand the thing whatever I wanted to tell you, that is process P5 will go for up to what millisecond? It will be go for up to 7 plus 2, that is 9 millisecond. We are not taking here 1 millisecond interval because all the process after P5 after 5 millisecond all the process has come. So 5 millisecond onwards we are not taking 1 millisecond interval, we are directly adding the burst time with the finishing time. So that's why 7 plus 2 9 milliseconds. So is it clear? It is 9? No. So I'm writing it once again. I'm writing these things once again. So it is 9. Okay. Now again process P2 has done. So among process P5 has done. So among process P1 and P2, whichever process has the least burst time, process P2 has the least burst time. So process P2 will be scheduled. It will be scheduled for 9 to 13 millisecond. Again, at, only one process is left. So P2 has done. Okay. Now only one process is left. That is P1, which has 6 millisecond burst time. So now P1 will be scheduled. P1 will be scheduled for 13 to 19 millisecond. Okay, so this is our final Gantt chart. Now we are going to find out the completion time, the turnaround time, and the waiting time. So for process P1, uh, what is the completion time for process P1? You can see the completion time for process P1 is 19. Why 19? Because you can see process P1 has completed its execution at 19 millisecond. So don't do a mistake. What we generally do, don't look at a glance and decide that process P1 has executed in one has completed its execution at 1 millisecond. No, please look at the entire Gantt chart and then decide. So you can see process P1 has come for 0 to 1 millisecond, and again process P1 has come to 13 to 19 milliseconds. So actually process P1 has completed its execution at 19 milliseconds. So we will write here the completion time for process P1 is 19. Okay. Next, process P2 has completed it at 13 millisecond. Sorry. At 13 millisecond. Okay. Process P3 has completed its execution at 6 milliseconds. At 6 millisecond, process P3 has completed its execution. Okay. Then at 4 millisecond, uh, process P4 has completed its execution. So 4 millisecond. Okay. Now you can see that at 9 millisecond, process P5 has completed its execution. At 7 millisecond, process P6 has completed its execution. Here you can see process P6 has completed its execution at 7 millisecond. Okay. So now it is the time to calculate the turnaround time for each process. So we know the formula for finding out the turnaround time TAT. For each process is finishing time or completion time minus arrival time. So finishing time minus arrival time. Okay. So the turnaround time for process A is 19 minus 0. Process P1 is 19 minus 0, that is 19. For process P2 is 13 minus 1, 12. For process P3 is 6 minus 2, that is 4. For process P4 is 4 minus 3, that is 1. And for process P5 is 9 minus 4, that is 5. And for process P6 is 7 minus 5, that is 2. And waiting time for process P1 is, we know the formula for waiting time. Waiting time is T minus B, that is TAT minus BT, that is turnaround time minus burst time. Okay, so uh, for process P1 the waiting time is 19 minus 7, that is 12. For process P2 the waiting time is 7, that is 12 minus 5. For process P3 it is 1, that is 4 minus 3. For process P4 it is 1 minus 1 0. For process P5 it is 5 minus 2 3. And for process P6 it is 2 minus 1, that is 1. So thanks for watching my video. If you have doubt you can write in the comment section, and don't forget to subscribe my channel. Thank you so much.